Good afternoon. I'm Gao Chengshan, and I'm from China Unicom.
Hello, I'm Jianfeng Ding. I'm from Intel OTC. Thank you.
Yeah. It's my honor to speak here. And today, my topic is an edge cloud architecture China Unicom case study. First, let me introduce my company, China Unicom. It's a very large company, and it has 263 million mobile customers, 67 million fixed network customers, and 75 million broadband customers. And its data center covers 69 countries and regions, include 28 POPs, 63 VPOPs, and also its market is present in 69 countries. It's a fully integrated service provider. Now this page shows you China Unicom's carrier cloud architecture. China Unicom released the network reconfiguration plan, CubeNet 2.0, supporting digital transformation. Its 5G network will be constructed based on 3-tier data centers as the regional, local, and edge levels. This page shows you the achievements in edge cloud of China Unicom. First, we built the global largest virtual edge cloud testbed in China. As a leading global telecom operator, we deployed the first virtual edge cloud testbed in Tianjin, China, beyond AT&T CMCC. It has the infrastructure include 10 IA servers and 4 Accelerator cards. We deployed Tencent Video, IT Video, Wall Video, and indoor localization, and others. Its implement business include video optimization, sync of CDN, campus security monitoring based on AI, VR, teaching, and so on. Based on the analysis of business scenario, analysis the requirements of the computing storage network and the accelerator resource of Edge DC. The second point is we proposed the first 5G edge cloud commercial resolution for smart stadium in 2017, Shanghai MWCS. In this project, our partners are Intel, Nokia, Tencent. We deployed 5G edge cloud in Mercedes-Benz Center in Shanghai, and we realized the multi-angle EVO and spotlight video in stadium. Holding China Unicom 5G Edge Cloud Conference and published the China Unicom Edge Computing Technology White Paper. This page also shows the achievements in Edge Cloud of China Unicom. We proposed the first video cost layer optimization based on Edge Cloud of China Unicom. Its practical effect is the scheme can adjust the application layer code rate and TCP congestion window mechanism according to the wireless channel and the resource. Also, according to the VIP information and other application layer parameters. It can provide users with wireless bandwidth resources and other security. The fourth point is we proposed the first Edge Cloud and AI intelligent security business platform. It's aiming at security problem of existing network, solve the problem of large wireless video, echo bandwidth, and unbearable end-to-end delay. Its practical effect is, in this scene, the video of 4G camera is processed locally by Edge Cloud reducing the use of bandwidth resource of the core network and shortening the time delay. Edge cloud executes the AI inference, local decision, real-time response. The last point is research on edge cloud unified platform architecture. We participated in the standardization of edge cloud. For example, ETSI, 3GPP, SA2, and CCSA, and so on. We built China Unicom MEC unified business platform, and we proposed the Edge APP end-to-end business orchestration management of Edge Cloud. This is about the future plan in Edge Cloud of China Unicom. The first is about the Edge Cloud construction of China Unicom. The network template of Edge Cloud expanded to 15 provinces, for example, Beijing, Shanghai, Fujian, and so on. Edge Cloud investment over 100 million in 2018. Previous research results have been included 2018 platform and pilot program with total investment of 89 million yuan. To 2020, we will construct 10,000 edge computing nodes, provide services to 1,000 enterprises, bear 30T traffic. The second point is about the platform construction. We were leading the initiative of OpenStack, open source organization, edge computing OpenStack virtualization platform with Intel, and submit the application requirements of China Unicom in Edge Cloud. We will contribute to the open source code with partner, build the maintenance and support team in OpenStack community, and promote the commercial progress of item, and promote industrialization process. The third part is about emphasis on the standardization. We will exporting the experience in edge cloud construction and deployment to ETSI, carry on the project of requirement of OTT. Then accomplish the 3GPP SA2 and CCSA item of edge computing, and participate in the ECC Alliance. Last part is build edge cloud ecosystem. We will build an open edge cloud ecosystem and be a leader in the industry chain. Build open source, controllable MEC edge PaaS platform, and accelerate the implementation of MEC commercial construction to jointly promote business applications. Thank you.
Yeah, thank you. Yeah, it's my turn. I'm going to talk about the accelerator devices management in China Unicom edge computing practices. Just now, Chen Shan has talked about the edge computing practice, the collaboration between China Unicom and Intel, because all the edge computing deployment is based on Intel devices, including the generic servers and some accelerator devices. You can see just now in the edge computing practice, we found there's many data processing need acceleration functions. For example, we have many video transcoding, some VR, the process, some security checking, and also we have a lot of AI or machine learning workload to be handled. So we need to use some hardware accelerator to speed up it. In the industry, we have several types of the accelerator devices. We can see maybe it's not all it's not a full list. I just list several typical ones here. For example, we have some NVMe interface, the high-speed storage as an SSD card. Yeah, we have a GPU. Yeah, we know. We have FPG with proper bit streaming burned and also in the left bottom corner, there's a two special card. Actually, it's a card from Intel. It's a QET card for the networking encryption speed up. So in the edge computing infrastructures, how we manage all the different accelerator devices and also the acceleration functions. It's open to us, to our edge computing deployment. Now, our choice is the Cyborg project in OpenStack. The Cyborg project in OpenStack is it's a relatively new project. We launched the new project about 100 years before. Firstly, we used the name Nomad, and after some discussion and a lot of discussion between different community projects, and 1 year before, we renamed the project to Cyborg. And from the time around the Sydney summit, the Cyborg entered a very active development stage. And currently, the Cyborg can be used actually with at least with FPG function enabled. Here is Cyborg's architecture diagram. We can see Cyborg have also several layers of services. The top one is the Cyborg API. The Cyborg API services can provide several APIs for the users, for the applications, also for the operators, for different functions. And for the request, the Cyborg API can pass down the request into the Cyborg conduct services. The Cyborg conduct services will record, will collect all the usage statistics data, and also record the inventory list to the database. And then the conductor will talk with Cyborg agent services. The Cyborg agent services will be run in every compute node. And for different type of the accelerator devices, the Cyborg need to provide different type of the drivers. The driver's function will be different. For some time is very, very different. For example, the FPG devices, if we want to provide the FPG operations, for example, we are programming. Yeah, it's a very typical FPG operations. We need to program the bit stream into it. So we need the Cyborg can provide the FPG driver to do so. And also for different vendors, we need a different driver code. For example, for Intel's FPG or Xilinx, we need different drivers. One more thing. The Cyborg driver also need to do the devices discovery and update the inventory list of the features. The following 2 pages, I'm going to talk about the 2 different typical FPG usage in edge computing. The first one is the pre-programmed FPG devices management. It means, AFAS, sorry, it's just a short name. It means acceleration function as a services. So the pre-programmed case is the operators or administrators need to use the specific tools to program the FPGA at first. So the programming, the orchestrator layer software will need not to care about. We need to handle the programming operations. It's by manually by the people. For the orchestrator need only to care about the scheduling, the discovering, the attachment, detachment, support only. From this diagram, the workflow will be at first on boot time. At boot time, the cyber agents will call the driver to scan the supported devices in the physical machine and recorded the inventory list information to database and also report the information to Nova placement services. Yeah. After the preparation in the runtime, the user here is the user, but the user can be considered maybe it's just an application or some SDK calling for etc. The user can call the API. Here the API means the no API to request some virtual machines with a flavor of acceleration functions. Then the Nova scheduler can co-work with the Nova placement services to search the proper physical node with available devices, accelerator devices. And then the cyber agent can continue do the hardware preparation attachment work and then the Nova can to return the proper virtual machines with acceleration functions attached back to the users. Next one is another scenario for the edge computing to use FPGA devices. It's orchestrator program mode. It means the orchestrator also need to provide some function to program the FPGA devices. And also the orchestrator need to provide some bit stream image management functions to be chosen by the user. The workflow is similar, but with several more steps. When the user requests some virtual machines with flavor of the functions, this step is the same. But the FPGA devices has not been programmed at this time. It's a cyber services duty. The cyber agent need to according to the flavor definition, the cyber agent need to find out the proper bitstream image from the image store. For example, the glass services with proper authentication or validation functions, and then programming the bitstream to the FPGA devices. And after the programming finished, then the cyber agent can continue to attach the FPGA to the allocated virtual machines. Yeah. One more thing about the FPGA support. It's actually the FPGA support in cyber for the China Unicom edge computing progress is already in our roadmap. Yeah, recently, our Intel upstream team are actively work on the Cyborg project together with the community, and at the same time, China Unicom team is to downstream the effort to their real practice. That's our status. Yeah, that's all for our presentation today. Thank you very much. Yeah. Questions you maybe.
So with the FPGA, is there any way to share those among the different VMs, or is it particularly like SRIOV, it's dedicated to one?
I see. In the FPG, how to say? In the FPG enabling work, for example, we need to provide the proper Linux kernel drivers to provide user space libraries script to do all the operations. Currently, for Intel FPGA devices, the upstream part has already supported the PCI pass-through for dedicated attached to one VM, but the partition feature, partition one single FPGA device to some VF to be used is on development. As the status, I think it's the upstreaming work into the Linux kernel should be soon, I think. Yeah.
And the second question, there was another project I was working on sharing the GPU compute.
Yeah, I know. Yeah.
Are you working with that project, or is this like alongside?
I think you are talking about the Nova support for vGPU, right?
Possibly.
Yeah, right. Actually, the vGPU support is inside the Nova project, not in Cyborg currently. But also, the Cyborg has the possibility and the potential capability to provide GPU management and vGPU management. Also, as I know, the Cyborg community has put the GPU support in the matter also. But yeah, in the future, I think two-way both can work. But yeah, in the long run, which one can survive? I don't know also. Yeah.
Thank you.
Yeah. Thank you. Okay, no problem. Thank you, everybody.